So let's move on to what we're learning today, solving systems with a different method. It's called substitution. Let's just read through this right here. Certain systems lend themselves to certain methods of solving that system. For example, number 1 on the class opener, the only one we did. The easiest way to solve it is by graphing. Why? Because both equations are in slope-intercept form, y equals mx plus b. And even more importantly, we know that they both have the b value of -3, which we know is the answer without doing any work. Now, I do apologize. There are actually a couple of typos on this page of notes. I'm sorry. So let's start by crossing this out. Or number 2 above. There is no number 2 above. So let's just completely disregard this. And not only that, this system right here, that should be a 12, not an 11. I apologize. So that's another mistake. It should say equals 12. Anyway, let's go back to this. Let's pretend that what I scratched out is not there, and let's continue. This system of equations is not completely ready to graph. That's what it says here. Yes, the top equation is ready to graph. It crosses at -3. You go up 2/1. You draw your line. But the bottom equation is in standard form, not slope-intercept form. So you'd have to modify it to get the y by itself. You'd have to subtract x, divide by 3. So you'd have to do some work in order to get it to graph. However, this system is ready for a substitution method, which we're going to learn today. So if we go down here, we'll see that we take the system with the 12, not an 11, rewrote it down here, and we're going to follow the steps, okay? So steps, step 1. And by the way, it says right here, teacher does it. So I'm doing it, and you're following along on your notes. Pick an equation and solve for a variable. So solve for a variable, that means get a letter by itself. And if you get to the luxury to pick either the top or the bottom, which one are you going to pick? Obviously, you're going to pick the top. Why? Because it already has a variable by itself on one side. It's already solved. See, if I pick the bottom one and I said, oh, I'm going to pick the bottom one and I want to solve for a variable. Okay, so I picked the bottom one. I want to solve for x. Then I would have to subtract 3y and subtract 3y. Or if I said I picked the bottom one, pick an equation, I pick the bottom one, and I want to solve for y. Okay, it says solve for a variable. Let's say you decided to solve for y. Then you'd have to subtract x. Let me actually show this. Subtract x, subtract x. By the way, don't copy this down, please. Just watch me. And then after that, you'd have 3y equals -x plus 12. And then you'd have to get y by itself by dividing by 3, dividing by 3, dividing by 3. Then you'd have y equals -1/3 x plus 4. That would be step 1. But why the heck would you want to do that if, when it says pick an equation and solve for a variable, the top equation already has a variable solved. It already has y equals. So it's already, step 1 is done for you if you pick the top equation because it has y equals. Now, it doesn't have to be y equals. It could be x equals. It doesn't have to be the top equation. It could be the bottom one. So let me go back and erase this because this is totally pointless to do all this work when the easiest thing to do would be to look at your equations and see which one has a variable isolated on one side of the equal sign. Anyhow, so step 1, pick an equation. I'm going to pick the top equation. Solve for a variable. It's already solved. Let's move on to step 2. So remember, I picked this guy up here, the top one. Step 2, substitute that variable expression. Okay, variable expression. What's a variable expression? It's the 2x minus 3. So it says substitute that variable expression into the equation you have not used. Okay, so we pick the top one, and then you're going to substitute the variable expression into the equation you have not used. So we have an equation down here, x plus 3y equals 12. We haven't used it yet. Notice that I'm going to take this 2x minus 3 and plug it in to the y. If you're thinking, why? Why am I plugging it in? Why am I plugging it in right here on the y instead of the x? Well, because it says y equals, doesn't it? Y equals this stuff. So here's y. So obviously I'm going to plug this stuff in right there. So the best way to plug in, the best way to substitute, in my opinion, is to take your equation and rewrite it. The bottom equation says x plus 3y, but remember, we're plugging in for y, equals 12. So I'm just going to put parentheses instead of y. And what am I going to plug inside those parentheses? Again, we're taking this junk, plugging it right in there. So 2x minus 3 is going to go right in here, which is going to go inside the parentheses. Very important you plug it in with parentheses. So you have the 2x minus 3 going in the parentheses. Why is it important to plug it in with parentheses? Because now you're going to have to do the third step, which is solve the equation that now only has one variable. See, the problem was originally this bottom equation has an x and it has a y. And you can't really get an answer when you have two variables. But now that we substituted, now we have an equation that only has x and x, which means we could actually solve this thing by simplifying the equation and then isolating the x. So let's do that. Let's simplify the equation. 3 times 2x, that is 6x. 3 times negative 3, that's negative 9. Let's bring down everything else. The plus, bring down the x. Let's bring down the equal sign, bring down the 12. So I've distributed. Now I'm going to continue solving. After distributing, we need to try to combine like terms, which we can. On the left side of the equal sign, there's 3 terms. 2 of them I could combine. The x plus the 6x. Now you're not going to actually write anything. You're just going to do this in your head. What is 1x plus 6 more x's? It's kind of like saying, what's 1 apple plus 6 apples? It's 7 apples. In this case, 7 x's. Okay? And then let me rewrite everything. Minus 9 equals 12. This is what we call a simplified equation. And now we want to get that x by itself, so I need to get rid of both the 9 and the 7. I need to get rid of the minus 9 first. How do you get rid of something? By doing the opposite. So you can go plus 9, plus 9. Let's rewrite what we have. We have 7x equals, because the minus 9 plus 9 is 0. It's gone. 12 plus 9 is 21. So now I have an even simpler equation. 7x equals 21. That really is saying 7 times x equals 21. We could already see the answers are going to be 3. But to get rid of multiplication, you do the opposite, division. So you're going to divide by 7, cancels out. The x comes down, the equal sign comes down. 21 divided by 7 is 3. And ladies and gentlemen, we have one answer. And that was step 3. We solve the equation, we get an actual answer. Actually, we still need more to step 3. And substitute it back into any original equation and solve for the other variable. You have an answer. If you stop here, you only get half credit. Because remember, a solution to a system is both the x value and the y value that make it a true statement, x and y. So you already have the x, you need the y. And it says right here, substitute it back into any original equation and solve for the other variable. So what we're going to do now is pick an equation. I want to go with the top equation. Looks a little easier to go with. Let me rewrite the top equation. Y equals 2 times x, but I'm going to put parentheses instead of x, minus 3. Now, why did I not write down x? Why did I put parentheses? Because x really equals 3. So what I want to do is take the x value, which is really 3, and plug it in for x. So I want to take the 3 and plug it in right there, of course, where the x is at. So plug in a 3 right there, and you will have your new equation, y equals 6 minus 3. And 6 minus 3 is really 3. So ladies and gentlemen, we have found our x value, which was 3. We found our y value, which was 3, which means that the answer to the system is the coordinate 3, 3. That means if I were to have graphed, if I were to have solved this system by graphing, the two lines would have intersected at the coordinate 3, 3. But on this section, we're practicing substitution. not graphing. So let's jump up here to the next one. Another one says teacher does it, you follow. So on this example, or this system, if I want to solve using substitution, first step is pick an equation. You could pick the top one, you could pick the bottom one. Now right here, the x is not by itself. It doesn't say x equals, it doesn't say y equals. It's actually in standard form. This is also in standard form. So after that, it's just totally up to you which one you want to pick. Okay, I would pick the bottom equation in this case because I see that this x is almost by itself. And in order to get rid of this x, I would have to subtract 5y, then I'll have x by itself. Step one is to pick an equation and get a letter by itself. Pick an equation and solve for a variable. So this one's pretty easy because it just requires one step. Up here, if you wanted to solve for x, you would have to subtract 3y, and then get rid of the 4 by dividing by 4 and dividing by 4. That's 2 steps. And not only that, you're going to end up with fractions. So the easier choice, if you think about it for a couple of minutes or a couple of seconds, is the bottom equation. So I'm going to pick this bottom equation and I'm going to solve for a letter. Now obviously it's easier to solve for x because all you have to do is subtract 5y. And you will have x equals negative 5y minus 9. So that was step one. Pick an equation and solve for a variable. Now, step two is to take that variable expression, talking about this over here. You see, x equals negative 5y minus 9. That's what x equals right now. And as you can see, there's an x on the other equation. So step two says, take your variable expression and plug it into the equation you have not used. That's exactly what we're going to do. I'm going to plug it up here, right into the x spot. So I always draw arrows all over my paper, all over my work, so I could see what I'm doing. Which means that when I plug it in, I'm going to have a new equation, and let me rewrite it. Instead of 4x, I'm going to put 4 parentheses because, of course, I'm going to substitute in place of x. Plus 3y equals negative 2. So there's my entire equation rewritten, but I'm plugging in the negative 5y minus 9 into the parentheses. Let me zoom in a bit. And of course, we're going to distribute here. 4 times negative 5y, that's negative 20y. 4 times negative 9, that's negative 36. Bring down the plus 3y, bring down the equals, bring down the negative 2. This is now an equation that has only a variable of y. All we need to do is simplify it. That's y distributed. Now I need to combine like terms. Negative 20y plus 3y, that's going to be negative 17y. So I really have negative 17y. Let me bring down the rest. Minus 36, right? That minus 36 just comes down. The equal sign just comes down. The negative 2 just comes down. And now I want to get y by itself, so I'm going to add 36 to both sides. And my new equation will be negative 17y equals 34. So now this is kind of ugly because we have a negative 17y, and we know that's really a negative 17 times y. So I need to get rid of the negative 17 that's being multiplied by y. So to get rid of multiplication, you do the opposite, which is dividing by negative 17, which do to one side, do to the other side. Now thank goodness this works out nicely, where you have 34 divided by negative 17. If you can't figure that out, use a calculator. You're going to get the answer y equals negative 2, and that is one answer. Okay, if you write that down on the quiz, you only get half credit because technically you only have half of the answer. Remember, an answer to a system, an answer is really a coordinate, an x value and a y value. So far you just have the negative 2 on the y spot. You still need the x to give a complete answer. So you only have half of your answer. How do you find the x once you already know the y? This is called substitution because we keep substituting, right? So we're going to take the -2 that is really y, and I'm going to plug in that y value of -2 into any equation I want. It could be the first equation or the second equation. Once again, I think the second equation is a little easier, but you could use the top. You're going to get the same answer anyway. Let me plug it into the bottom equation. I'm going to start by plugging it in, by rewriting it. The bottom equation reads x plus 5y, but instead of y, since I'm plugging in -2 for y, I put it in parentheses, equals -9. Same equation, x plus 5y equals -9, x plus 5y equals -9. Y is really -2. So I'm going to take the -2 and plug it in right in there, -2. Let me continue solving this new equation. It says x plus -10 equals -9. And then to get rid of the -10, I add 10 to both sides. Final answer is x equals 1. So you put a 1 right here, and that's your final answer. 1, -2. If you were to have graphed, changed it to slope-intercept form, changed it to slope-intercept form, graphed it, you should see that they intersect at the location of +1, -2.